Moving forward with ozonolysis, it's time to review and do some practice problems of both the oxidative and reductive workups. Looking at our first problem, we can see that it's a reductive pathway. The first workup we learned of ozonolysis, treating the secondary ozonide to dimethyl sulfide, a mild reducing agent to free our carbonyls. This process leaving us with ketones and aldehydes, maintaining those formal hydrogens throughout the workup. The second workup we learned was the oxidative workup, which treated the secondary ozonide to heat, resulting in the freeing of a carbonyl and carbonyl oxide, which were treated with hydrogen peroxide and water, leaving us with a new intermediate, a hydroperoxy acetal. Even though we didn't go over the specifics on how these intermediates rearrange into carboxylic acids, we'll keep note that it's through this intermediate in which the oxidative workup results in the formation of carboxylic acids and carbon dioxide if we formed formaldehyde. Reviewing the problem again, we can see that our answer is now a carboxylic acid and carbon dioxide. Now let's do some practice problems. There's going to be 2 sets of problems. Throughout each of the set, pause the video if you're interested in giving them an attempt. With this first one, we have a linear structure with one double bond, treated both through the reductive and oxidative pathways. In one, we will form a ketone and an aldehyde, where in the other, we will have a ketone and a carboxylic acid. This next question is asking which workup can we take to form these products. Since we have carboxylic acids, the best bet we can take is the oxidative workup. We have multiple double bonds in this cyclic structure, that's why we result in 2 individual linearized products. Next, let's do some practice with some slightly different problems. Pause the video if you're interested in trying the second set of problems. Since the starting material of our first question is a cyclic structure where each of the carbons has a hydrogen, will result in one linearized product where each of them is a carboxylic acid. Throughout this question, we have a linear structure with 2 double bonds undergoing the reductive workup. We will cleave each of the double bonds, and since this is a reductive workup, we will maintain those formal hydrogens in our products. And here are the 3 products of that reaction. I hope this review and practice of ozonolysis has been helpful and helps with your continued studies. Best of luck.